Mesdames et messieurs, bonjour, bienvenue. Welcome to this very special TechWorks webinar today, following the Memorandum of Understanding between TechWorks and the Canadian Semiconductor Council last year. The two organisations are working on practical opportunities for collaboration between the UK and Canadian semiconductor ecosystems. You'll hear more about that in a few moments, but first, just whilst everybody arrives, I want to tell you about a very special major event taking place next week on Wednesday, the 26th of August at the Novotel London West in Hammersmith. This year, TechWorks is celebrating its 30th anniversary, and to mark this milestone, we're holding one huge event where all of the individual TechWorks communities will come together under one roof for one day. It's the TechWorks Semiconductor to Systems Summit, and it will be made up of the NMI 2026 conference, the 2026 IoT Security Foundation Conference, and the ASIN and Design conferences, as well as a track by the UK Semiconductor Centre. So that's all happening next week. Tickets are incredibly close to sell out. So if you'd still like to come, please go to techworks.org.uk. You'll see the event details there. Get yourself registered. If you're a TechWorks member company, entry is absolutely free, but move fast. Like I say, tickets are about to sell out. So one of the international delegations that we've got coming to the event will be from Quebec. They are Canada's Semiconductor Council, and we're even holding a VIP reception at Trafalgar Square's Canada House on Tuesday evening for them, so looking forward to that. So today, ahead of next week's conference, the following presentation is entitled Exploring UK and Canada Semiconductor Collaboration, an Introduction to C2MI, with Annie Dallaire, who is in Bromont, Quebec. Before we hand over to Annie, I'd like to introduce Charles Sturman. He is the CEO of TechWorks, and he's going to give a little bit more detail about this special collaboration. So we now cross over to Cambridge, and here's Charlie.
Hi, thanks, Chris. And thank you all for joining, and special thank you to Annie for spending the time to share some information about what C2MI is doing and the broader landscape in Canada in terms of the semiconductor ecosystem. As Chris has already said, we have worked quite hard at TechWorks over the last few years to build not just connections and relationships across the UK, but also internationally. And really the strongest relationship we have today, I would say, is with our friends in Canada through the Canadian Semiconductor Council. Already last year, we worked with CSC and the Canadian High Commission in London to bring some of the Canadian companies to the UK. And then Innovate UK did a return trade visit to Canada, taking some of the UK companies over to Canada. And this relationship is only growing stronger. As Chris mentioned, next week at the Semiconductor to Systems Summit, we have a delegation from Canada coming. We also have delegations from Japan and Saxony and the Netherlands coming as well. We will have an international collaboration panel in the afternoon on the scale track. But in terms of the Canadian relationship, and Annie will talk a bit more about this, there have already been some activities, collaboration activities going on between C2MI and UK entities. And I think what's really exciting here, and the reason why we wanted to build this relationship, is that the UK and Canada in particular have various complementary skill set and technology areas around compound, semiconductor, photonics, wide bandgap. If you look at the broader ecosystem, OEMs and applications areas, there's a lot of complementarity in automotive, aerospace, and other systems areas. And frankly speaking, from a kind of relationship and culture and compatibility of doing business together, we really do think very much in the same way. So anyway, look, without any further ado, I'm going to hand over to Annie for what I'm sure will be a really interesting presentation, and a message to everyone online. If you want to know more, drop us a line at TechWorks, either Chris, myself, Annie, I'm sure will provide some details during the presentation. And we are very keen to do what we can to bring our mutual ecosystems together, to work together to develop business for both countries. So thank you very much, and thank you. Over to you, Annie.
Thank you, Charles and Chris, for the introduction. So it's a real pleasure to have the opportunity to present C2MI area of expertise. And I'm excited to share how we support innovation and help bring technology from concept to commercialization. And I fully agree with you, Charles. Overall, the country that we work with, we found that the UK is the more similar to us as the mindset of development. So let me share my screen. This one. Share, and then I'll put this in presentation.
Annie, just whilst you fiddle around with that, one thing that I forgot to say, if anybody's got any questions for Annie during this presentation, if you want to know more about what you're seeing, or if you've got any comments, please put them in Zoom chat and we'll ask those to Annie at the end. Right. Sorry, Annie, we can see your slides. You're ready to go.
Yeah. Okay. Thank you. Yeah. Okay, so let me start with a quick overview. Like Chris and Charles said, C2MI is the largest industrial innovation center in Canada, dedicated to microfabrication and packaging. We are located in the province of Quebec, a city called Bromont, about, I will say, 1 hour south of Montreal. So what makes C2MI truly unique? So our mission is simple but powerful. We help our client to develop and refine manufacturing processes. Our facilities are equipped with industrial-grade, state-of-the-art tools that meet the highest standard, just like a full-scale production site, meaning that we have preventive maintenance, qualification every day. So when we do development, we can guarantee the quality of the facility and the equipment. And we then offer a seamless transition from prototyping to market launch. And of course, it's not just about the equipment. Our team of highly skilled professionals work hand in hand with clients to scale up to high volume manufacturing, no matter the size of the project. So it's a real lab to fab journey. And maybe I should have said at the beginning what C2MI stands for. So C2MI stands for, in French, of course, so it's why the letters are inverse, but for Micro Innovation Collaborative Center. So collaboration is really at the heart of our work. So, well, in fact, C2MI is designed as a one-stop stop for company developing microelectronic processes. Under one roof, we bring together our complementary area of expertise. First, we have a MEMS, quantum, and silicon nitride photonic pure-play foundry on 200 millimeters wafers. We also have a packaging and optoelectronic assembly sector, a printed electronic and a card assembly line, and a fully equipped analytical lab. Each of those pillars, play a role in supporting innovation, but it's really open to any kind of project that can require one or more of our expertise. So before I dive deeper into our capability, I'd like to show you a quick video that in fact is a virtual tour of C2MI. It's just 2 minutes, but it will give you a glimpse of our facilities and infrastructure. So hope this is gonna work. So let's check it. here. Okay, so hope you enjoyed that. As you saw, our infrastructure is a world-class and built to accelerate innovation. So now let's explore a bit more our expertise. So let's start with MEMS, so microelectromechanical system. These devices are the art of today's tech revolution, bridging the physical and digital world together. So from accelerometer to gyroscope, pressure, temperature sensors, MEMS enables smart interaction with the environment. They also perform precise movement, which are essential in fields like medical micropump and advanced optic. So at C2MI, we really push the boundary of MEMS manufacturing and assembly. So you come to us if you have a new idea, a new MEMS to put on the market, and we partner with you to turn your idea or concept into a scalable, exclusive manufacturing solution. Like I said, we also have photonic platforms. So on the photonic side, we offer fabrication of silicon nitride waveguide. But since we have a lot of expertise in MEMS as well, so we can couple that to advanced technique like doing a suspended waveguide, a facet mesh, or V-group. So I also have in my presentation most of the equipments that we have. I don't want to go through each and all the detail, of course, but if required, I can share this presentation at the end, no problem, so that it gives you a bit of what we have, but I will go very quickly. So of course, like I said, 200 millimeters wafer, like a pure play foundry. So you come to us with your design and we develop a process for you. We have many equipments to do photolithography, of course, code develop a thin or thick photoresist or polymer. We have a lot of metrology, all in a production mindset. So all in pattern recognition approach and full automated tool, as you can see. We can etch your wafer, the films, of course, dry etch, wet etch. We have a pretty good bonder to do all kind of bonding of wafers. Since we start with a MEMS foundry, we can release structures. So we have vapor HF or xenon fluorized release, TMP as well. Many films that we can deposit from vertical furnace, thermal, PVD, CVD, or plating as well. What else? The metal sputtering, of course. We do have a ALD, and we even have a ion beam trimming, so to trim the surface of the wafer for nanometer scale adjustment of your thin film or directly the silicon. So like I said, very, very quick. Don't want to spend too much time on that, but I'm happy to follow with you if you need more detail or have some question. Second expertise, packaging and optoelectronic assembly. Here again, our clean room offer a wide range of process tailored to meet the need of next-gen device. So all kind of packaging that you can imagine, we can do it. So we start with the wafer. At wafer, we get backside grind, blade dicing or steel dicing wafer. We can start on 300 millimeters wafers down to as small as you have. We can pick the die, of course, but many of our die placement machine or component placement machine can directly pick on wafer or pick on gel pack or whatever format that you have your part. We have many die placement tools that are able to meet a lot of requirements. So really depending on the project that we work with you, we will choose the right one to adjust for your requirement and be sure that we use the more cost-effective tool for your production afterward. Of course, electrical interconnection. So we can work with the C4, copper pillar. We are pretty strong in wafer wire bonding. So we have all kind of wire bonding. It could be ball bonding, wedge bonding, ribbon bonding of gold, copper, aluminum. We have all the possibility or expertise as well to do lead attach, diamond field, and since we are in the optoelectronic field as well, we have a lot of expertise to work with optically clear adhesive if required. Just to continue on the optoelectronic assembly, so we are able to do a full passive or full active alignment of any component. So we have some semi-automated benches that we work with to develop the process, but when it's developed, we have a full automated tools able to do active alignment of component and wave fiber optic as well. And we also have this new technology usually called photonic wire bond, where you can 3D print a photonic wire bond interconnection. But with this tool, we can also nano print a free-form coupling element. Okay, that was the second expertise. Third one then. So to further support the product development, C2MI has had two essential sectors, printed electronic and a card assembly. So these capabilities allow us to support even more diverse and customized projects. So we offer a full suite of tools to build your circuit, from ink deposition with various materials to photonic or thermal curing, lamination, soldering, and even laser drilling at the end. And we can assemble and integrate all the components you need. And to complete this area, we have a full automated SMT line as well. So as for our fourth expertise, it's our analytical lab. It's sure that we use this lab every day when we do the developments in the all the other expertise, but we can offer lab analysis as material characterization or failure analysis, and we also have reliability testing as a standalone project. You know, you don't need to work with us for the development of your product to use our lab if you need. So here again, I have a few slides to showcase what we have, but I will keep it brief so that you just have a glimpse of what we have. So non-destructive techniques, of course, X-ray, acoustic microscope, time domain reflectometry, all the electrical and impedance measurement, etc. that we have. We have a lot of tools to do material characterization, chemical thermal characterization. We also can do destructive technique as well, so cross-section with plasma fib if needed, or ion milling to see what's happening. And like I said, we have a full reliability testing area when we can test your product to be sure that it meets the requirement of your market. Okay, so now let's look at it. So we've just completed a major expansion of our facility, and now the clean room is ready to welcome equipment for emerging technology. So I don't know if you see my pointer, but this is the office area, and this was our facilities 1 year ago, and this is completely ready now. We have doubled this the wafer fab, I will say, area to be able to continue to improve our expertise and offering, I would say. So a third of the space is dedicated to quantum chip fabrication. So C2MI will be probably one of the first pure-play foundry for supraconductive quantum chip on 200 millimeters wafers. So it's making a major step toward industrializing quantum technology. So to support this advancement, new equipment will enable the fabrication on 200 millimeters wafer of Josephson junction and the production of supraconductive TSV for 3D packaging. So here again, it will be the same mindset, only industrial tools, full automated cassette to cassette that will be maintained as the standard of our production centers. This assembly sector will also be enhanced to include not just that, but among other things, capabilities of enzyme microbumping and high pressure compression to be able to package the supraconductive die. But it's not all for the quantum. So as I said, we also have a silicon nitride photonic platform. And this platform is going to be enhanced and improved to be able to have the performance needed to address the demand of quantum photonic as well. So here again, investment in equipment to improve our losses, I will say, be able to work with different wavelengths, and also the packaging to adapt the packaging as well. So the rest of this expansion, the rest of this expansion will be more focused on advanced packaging. So as you know, advanced packaging is becoming a key enabler for performance, density, and energy efficiency. So modular chip integration allows specialized components to be combined with in a single package. So to support this evolution, we are expanding our capability to add, but it's not all here again, technology like a copper TSV, hybrid bonding, wafer level bumping or copper pillar, and post-processing on top of CMOS. So we already do post-processing on top of CMOS, of course, but on 200 millimeters wafer. Now all those expertise, we bring them for 200 and also 300 millimeters wafer. So those set of equipment will be our first set that will be compatible for 300 millimeter wafer as well. So in fact, majority of them are what we call bridge tools, so they can do both 200 and 300 millimeters wafers, but in some case we need to have two equipments, and that would be the case. So we're gonna have a 200 and a 300 millimeters wafer equipment. Okay, so that was very quick overview of our expertise. I just want to emphasize that at C2MI, we are deeply committed to support innovation in microelectronic, photonic, and quantum technology. And we really act as a bridge between applied research and industrial commercialization, helping a company move from prototyping to market launch. It's like helping to cross this famous, infamous valley of death between innovation and commercialization. So our business model is very flexible. We are open to any size of project, including one or more of our area of expertise. And we are proud to support innovation projects from clients around the world. And not just for startup, we work with SMEs as well and very large multinational companies. So before I conclude, I would like to highlight the outstanding collaboration between Canada and UK that we've done. So what Charles explained a bit at the beginning. So I will say, well, maybe almost 2 years ago, we had this first commercial mission that Canada went to UK, and after that, like Charles said, the UK company came to see us here in Canada. And during this collaboration, we learned about your capabilities, and we decided to do a collaboration, Canada and UK, that demonstrate how the strength of both countries can be combined to create a seamless pathway from innovation to commercialization. So the project aims to demonstrate a co-packaged optical engine for AI data center application. So the prototype was really developed by leveraging the expertise of each partner across the value chain. So you have the value chain here. So the design of the chip, the design of the PCB and housing was completed by the UK partner, who is CSA Catapult Innovation Center. The laser was designed and fabricated by the CPFC, that is the Canadian Photonics Fabrication Center located in Canada, the province of Ontario. And C2MI was responsible for the fabrication of the PIC die, as well as the assembly of the prototype. Finally, CSC Catapult is leading the testing and the validation of the prototype, so to see if what they have designed really happened at the end. And I can tell you now that the results are good, so it works. And also, what was really remarkably is the entire project was complete in just 6 months from the first time we decided to work together to the delivery of the first prototype. So this demonstrates an exceptionally efficient and successful journey from concept to realization, while showcasing the power of international collaboration in So my conclusion now, so thank you for your time and attention. At C2MI, we believe that collaboration is the key to unlock technological breakthrough, and we look forward to work with you and turning your ideas into market-ready solution. So you have my email here, like Charles said. If you want to contact me, please be free, and I can share, of course, the presentation if you need.
Formidable. Merci beaucoup, Annie. So actually, that is one of the questions that we've had on Zoom chat. Can we have a copy of the slides? So, Annie, following this broadcast, if it's okay with you, if you want to email the slides to me, I can pass them on to everybody else who's watching this webinar broadcast live.
Yes,
we've already got questions coming in on Zoom chat, which is absolutely fantastic. I should give a little bit of an update, by the way, for something that I was saying earlier. We're now sold out for next week's conference in terms of free passes for TechWorks company members. Only paid entry is now available, and those are now selling out fast as well. So if you still want to come, get yourself registered, because it's about to be the case that if you don't do it now, you won't be able to get in at all, I'm afraid. So please do move with haste. Okay. First question that's come in, Annie, on Zoom chat is from Peter. What is the smallest feature size you can fabricate? Do you have electron beam lithography, sorry, for sub-micron feature sizes?
In the quantum fab, yes. So in fact, we are in the process of acquiring a e-beam litho that will be ready to use in a few months from now. But by the meantime, if you need to work with us now, we have access to one in a university nearby. But yes, it will be the objective to have it in the quantum supraconductive fab. But the quantum supraconductive fab, unfortunately, needs to be isolated from our MEMS and photonic fab for cross-contamination reason. So on the other side, if we cannot work on the side of the quantum, for now, we only have a 5x stepper that is able to bring the smaller feature, let's say let's say 300 nanometers. But in this enhanced photonic platform that we want to have, we're gonna have a deep UV stepper that will bring the feature down to 100 nanometers. So it's really depending on the process and where we can make it. but I will say that we can have some very small feature with the e-beam litho if we can work on this side of the fab.
All right, thank you very much for that question, Peter. And this is what happens when I don't wear my glasses. Electron beam lithology, lithography. Thank you. Okay, Lynn just says, excellent presentation, Annie. Thank you. Also, Charlie has come back on to say thanks so much, Annie, for a great overview, and we'll speak soon. Who else have we got? Norbert, Marie. Thank you, Annie. Great. Bonsoir. It's not actually evening here in the UK.
No, it's morning for me, but it's okay.
Well, it's evening somewhere. Certainly
Yes,
not in
it is.
Scotland, anyway. Where are we? Lynn, she asks, are there specific funding opportunities still available to companies for collaboration? That's more a question for TechWorks. Example, Innovate UK, etc. Lynn, I'm going to pass that inquiry on to Charlie. And Charlie can get back to you on that one. So thank you very much.
Yeah, Chris, if I'm still lurking.
Charlie, you're still here.
I've got to jump onto another call very shortly. But the short answer, Lynn, is that, as you may be aware, last year there was quite some delay in due to the changes in the government. Quite some delay in terms of the future funding picture for Innovate, and that's all clarified now. So there's quite a lot of activity going on at Innovate right now. I don't know off the top of my head, but I can certainly take that away and look into it. Annie, I don't know if Annie knows any more, but what happened 18 months or so ago was that the Canadian government and the UK government both set up a pot of money for funded collaborative projects. And the concept was that a UK company would be responsible for looking for a Canadian partner and vice versa. And then that funding would be available in each respective country to support that joint collaboration. So I don't think I've explained that terribly clearly, but the idea was that you would go to Innovate and look for a funding opportunity. A Canadian company would do the same in Canada. And if both of those discussions go positive, then the funding could happen and you would do the collaboration together. And that's kind of how the Catapult C2MI kind of collaboration operated. That concept of doing kind of bilateral mutual funding is still in discussion within Innovate and the UK government, but I don't know if there is an active funding opportunity right now. So we can look into that and get back to you.
Mm-hmm.
All right, thank you very much for that, Charlie. Nice one. Where were we?
Also, maybe if I can add, Canada is a country that is eligible for the European program like Eureka and Horizon as well. So if you have, you need to have many countries to work with on those submission, I think, of project. You can think about Canada. We are eligible in that.
All right, thank you very much. I'm just scrolling back again through Zoom chat. Chris says, thank you for the excellent presentation, Annie. Greetings from all of us at CSA Catapult. So you're making friends. Okay.
Yes, I know them.
All right, you're acquainted already. No problem at all. Here is a question from, I hope I'm pronouncing this name correctly, Manus. Thank you for the presentation, Annie. You mentioned GaN and photonics. So does that include, I'm not sure, this is esoteric language, excuse me.
Arsenide base.
Thank you very much. Also, a very specific technical question. Do you have ICP and what endpoint detection system does it have?
That is very precise. You're right. We do have ICP. And I think that the endpoint detection is with the by looking at the byproduct in the chamber, but well, I will need to confirm that. For GaN nitride, so we work on GaN nitride wafers. In fact, it's very nice to have full automated tools, but that means as well that we can only handle 8-inch wafer, 200 millimeters wafers. So as long as your wafers is 200 millimeters wafers and soon 300 millimeters, we can probably work with you and we can develop the process. But most of the time, gallium arsenide base wafer are smaller than that, and this limits us on what we can do and work with you. But if you have any needs on, and you can have those wafer on 200 millimeters, we are certainly open to work with you.
Okay, thank you very much. We've still got time for a few more questions. Where are we? Is C2MI a government institution, Annie?
No. In fact, C2MI is an independent non-for-profit organization. So we are not part of the government.
Okay.
We do receive some government funding, but it's primarily to support our capital expansion and infrastructure. All the operational costs are funded through the project that we have with the customer.
Okay, fantastic. What are the requirements to start a project with C2MI?
Yeah, good question. So I will say that our ideal customer have done some kind of proof of concept. So because we really bring the developments to a manufacturing stage. So when you have done a proof of concept, you know that you have a working concept, then C2MI will help you to develop the manufacturing processes. So we don't do design at all at C2MI. So you come with your design. If it's at the packaging area, you need to come with your full bump, and your idea of how you want to, what you need to put all together, I will say. And then we're gonna help you to develop the processes. But we can help design for manufacturing, I will say. So we will work with you in close collaboration to be sure that all the requirements that you have are met, and place where we can have some margin to use standard process that we have already developed, we can reuse it. Okay, so we really work to be sure that we use as much as possible already developed process, and we focus only on the part that are specialized for your product, that put your product on some edge compared to the market or the other product.
Merci. How is intellectual property managed at C2MI?
Okay, so like I said, we don't do design. So project design is always yours. We don't take anything in that, and it's gonna stay yours. For the process that we have developed, we have a very special, I will say, or flexible IP model. So everything that we have developed for you will be shared to you. And if it's like we give you a non-exclusive free license to use it, but we can reuse it as well for other development. So it's like the way that we build our expertise. So at C2MI, like I said, we develop manufacturing processes for you. We can do prototype, but we can do also small volume. But at some point, your volume could be too high for us, and it's where we're gonna help you to move to an industrial partner able to take the high volumes that you have. So we do have some partner that we work with and know that the transfer is feasible and not easy, but we can do it. And it's why we need to transfer this process that we have developed for you to those industrial. But you are not buying with any industrial. If you have your industrial in mind that you want to work with in the future, you can still come to C2MI, develop all your process, and then when you're going to be ready, we're going to help you to move to this industrial partner that you have. So that is really what makes us different, I will say, to all similar, I will say, innovation centers that you can find in other places in Europe. So it's really, we don't take any license on the process that we have developed for you, and we're going to help you to be sure that we never let you down, I will say. So I have many customers that ask what is a small volume and what is high volume. It's really depend on your process. It really depend of the tools that we have, etc. So we will make sure that C2MI will help you to put your product on the market until you have another supplier that can take the ball, you know. So if you are too small, too big for us, you will be definitely big enough for another one. So we will make the transition easy so that we never let you down, and you're gonna have your place to do your developments, do your prototyping, and do some volume production to put your product on the market.
Okay, Manis has just got a follow-up comment to say, thanks, Annie. We are working towards 200 millimeter with IQE.
I don't know who they are, sorry.
Maybe I've confused you. Hang on a second. Blah, blah, blah. Manis was asking about GaN before.
Yeah, so, well, I think it means that is GaN arsenal base wafer are 200 millimeters, so that's perfect. Sorry, I don't know IQE who they are, but maybe we can have a follow-up discussion together to see.
Manis, if you've got 10 seconds and you can type very quickly because we're about to wrap up, do you want to clarify that just for anybody who might be a little bit confused? Let's wait on Manis typing at a rapid rate. There he is. IQE is the world's largest EPE fab.
Okay, sorry. Yeah, that's perfect. So probably that we can have a fit then.
All right, fantastic. That's us at the end of this TechWorks webinar special, I am sorry to say. So thank you so much, Annie, for joining us today. As I said earlier, I was going to say to close out this special webinar broadcast that tickets, get them very quickly for the TechWorks 30th anniversary conference next week. They are sold out. The only tickets that are now left are the ones that you have to pay for. So thank you so much to everybody who will be coming to the event. Your support is much appreciated. Annie Delard in Quebec. Merci beaucoup. Je m'appelle Christophe. Au revoir.
Au revoir. Merci beaucoup.